to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Vladimir Khoriko, who is the author of the book titled Unit Testing Principles, Practices, and Patterns, which was recently published by the good folks over at Manning Publications. Vladimir Khoriko, welcome to Maintainable.
Thank you. Thanks for having me.
So given your experience in our industry, what do you believe are a few common traits that a software code base is being well maintained?
So there are a lot of, I think, traits that people can attribute to well-maintained code bases, but the most common ones, I think, are external and internal traits. And the external trait is basically the number of bugs that you introduce with new changes. Well, I think both of them, external and internal, they kind of work together and one influences the other. And that's why you can basically have them both as two components of code maintainability. But an internal one, I think the most important but least discussed trait of the internal component is how well your domain model or business logic is isolated from external services. So that's, I think, a very important topic that is rarely discussed nowadays, but it's really important to isolate your business logic from the influence of the outside world so that you can focus on that business logic without distracting yourself. Because the business logic of your application is hard enough to deal with already. And if you introduce other concerns, such as, for example, your database or talking to external services, that would increase its complexity exponentially, and you don't want to do that. And so one of the most important traits of a maintainable code base is how well you separate this part of your application, its business logic, from everything else.
And you were talking about external and kind of reflecting, you mentioned specifically bugs, because this is kind of like a little bit of a new thing for me too. So I'm just trying to wrap my head around this a little bit more. Between if a bug, let's say hypothetically, is occurring, and these are some external things that are happening within the application, is that not be due to the business logic?
So by external, I mean something that is observable by someone else other than developers. So that's observable behavior of your application, if you will. Usually when the code is not well maintained, it manifests itself in one of two things. It's either the code takes you a lot of time to maintain and to release new versions, or if you try to cut corners and maybe reduce the release cycle, it leads to introducing bugs because you don't have enough time to test everything and to make sure that everything works. And that manifests itself in something that your clients can observe. And that's usually what they can observe and is bugs.
I see. I want to kind of dig into this a little bit more on the external versus internal. So let's say if you are a user of a software application and the release cycles are pretty slow in terms of getting it. Like if you're waiting on a new thing because behind the scenes maybe a development team is working on refactoring something or maybe some bigger upgrade, is that kind of in the same realm of this external versus internal?
Yeah, so in this case, the external part would be the increased release cycles. You don't want to do that either. But yeah, when your code is not well maintained, you have to choose one of the two not very good options. Either you will need to increase your release cycles, or you will have to introduce a lot of bugs in your software because you will not be able to fix them all within the short time frame because of the code quality.
Right. What's your current take on the metaphor technical debt? Do you use it in your practice? And if so, how do you define it?
I think that it's a useful term, but people often attribute to technical debt things that don't really belong there. For example, a lot of people just say that a bad code is a code with technical debt, but it's not the case. So bad code is just code that is messy. It's not a code with a lot of technical debt. And technical debt, at least for me personally is something that you intentionally put in your code base, something that you did just to shorten the release cycle, just to, for example, to get to the market quicker than you would otherwise. But when you write bad code, it's not necessarily the same as a code with technical debt, because you can write messy code just because you don't have enough knowledge about how to do it properly, or maybe requirements changed and you didn't have enough time to fix that. So this term is often used when people try to cut corners and try to maybe release the software quicker. One of the easiest way to do that is to reduce the scope of your software instead of reducing the quality. So the way I think about it is, if you can imagine maybe a rectangle with some width and some height, and the height of that rectangle would be the scope of your release, and the width of that rectangle is the quality of your code. And so what people often try to do is they try to reduce the width of that rectangle, meaning that they try to reduce the quality of their code base. But a more proper way to do that is to reduce the height of that rectangle. So you need to reduce the scope, but not the quality of the code, of the resulting code. That would basically allow you to do the same thing. So it will allow you to release the software quicker, but without many detrimental effects that will bite you down the road.
You know, you make a couple of good points there about how technical debt being an intentional thing, and I'm glad that you also touched on that it's not necessarily bad code, and that some developers will mislabel bad code or things that they disagree with as technical debt because it's a phrasing that people seem to have learned in our industry and hear about through different teachings and writings and authors and stuff like that. But I think there is a good distinction there. And do you find that there's some ways that people, like engineers specifically, when they're talking with other stakeholders, often miscommunicate about technical? Do you feel like you find some ineffective ways about how they try to raise those concerns?
Yeah, pretty often. So what developers try to do when they communicate issues with the code base to higher ups is they try to ask for a specific sprint that they call a technical sprint, during which they will be fixing some issues with the technical debt. And what they fail to communicate is how this will affect the project afterwards. So they often try to word it from the programmer's perspective. So let me just fix maybe some things here, clean up the code base there, maybe refactor the database, the domain model, and everything will be much better afterwards. And what the managers hear when they are communicated in such a way, they hear that they will need to spend some 2 or 3 weeks just to do nothing. There is no cost benefits from their perspective. So there are costs, but no benefits here. And what you need to do instead is you need to communicate what benefits they will have after that refactoring. So, for example, and you need to put it into words that are close to your manager's perspective. So, for example, if you had some really bad bugs in production that costs you money or just bad reputation among your clients, you could say that, well, we introduced this bug not only because we tested it, we did not enough testing, but also because the code was of low quality. And so this way you will be able to phrase it in such a way that the managers will see, that the cost of this fix is going to be 2 weeks, but the benefit of that is going to be that now we will not have as many critical bugs in production as we had before. So that's one way. And another way that I see people effectively do, so what they do is they don't mention it at all to the managers, and they just quietly maybe refactor some things here and there during normal sprints. And when they estimate among themselves, they just add up additional time to maintain, to clean up the existing code base. This also may be an option because refactoring is something that you have to do continuously anyway, and it's just part of your job. Just like, for example, writing unit tests is part of your job, and it's not necessarily something that needs to be communicated to your managers, unless, of course, it's some this refactoring will require a lot of time. For example, a full rewrite is something that is clearly needs to be communicated with the managers, because full rewrites usually require a lot of effort, time, and money from the company.
Right. And we'll dive into some of those topics in a little bit as well. But I think you make some good points there about how selling the benefits and the value to the business about, if you're trying to bake in some of that into your work. And, I think sometimes, and we'll talk a little bit more about this in a little bit, but I think there's some good takeaways there for sure. I want to take a quick step back and learn a little bit more about you, if we could. So you recently published a book about unit testing with Manning. And I know there are a number of books out there about unit testing and writing automated tests. What do you believe sets your book apart from previous ones?
Yeah, so there are a lot of, as you said, there are a lot of books that are really good, and I learned a lot from them. But what I found is most of those books are basically for beginners, and most of the online material that you can find is also for beginners. So they start from the very, very beginning, from the ground up. So, for example, let's try to write this first test and see how it goes. So, as I said, these books are good, but when you have some experience with unit testing, when you already know some basic things, there is not much you can read or learn from to get yourself to the next level. And with this book, I tried to fill this gap. I tried to provide the guidance for developers who already know how to write unit tests, already did that for maybe 1 year or 2 years, and want to learn further.
Nice. And what are the examples using? What programming language are you primarily using throughout it?
The examples in this book are written in C#, but that's just because C# is my primary language. It doesn't really matter what language you will use, because a lot of concepts are directly transferable to other languages. So you can replace the examples with pretty much any object-oriented programming language, such as, for example, Java, C, JavaScript, and so on. So it doesn't really matter.
That's awesome. Great. So let's just take a moment to assume that there's some people out there listening that have maybe heard about unit testing or automated testing. And it's kind of like a concept, and maybe they've not yet even maybe taken that first step, or maybe not gotten that far into the process because their team that they're working on doesn't really follow like a test-driven development methodology at this point. But can you talk a little bit about like where the line between like unit testing and, let's say, integration tests might look like for developers, to try to understand kind of where the difference is and where a unit test kind of fits into that ecosystem of automated testing?
Right. The line is quite blurry, and it's not as obvious which tests you can categorize as unit tests and which as integration tests. In the book, I draw the line between the two as using three characteristics, three attributes. So a unit test is a test that tests a single unit of behavior, does it quickly, and does it in isolation from other tests. And so if you take this definition, then, for example, tests that work directly with your database, they don't fall into this categorization, and thus they will automatically be categorized as integration tests, because if your tests work with the database, they will not be isolated from other such tests that work with the same database, unless, of course, you run a separate instance of the database somewhere in Docker container before each test run. But usually nobody does that. When they test database, they work with one instance of it. And so that's a technical definition. But in practice, you can basically say that a unit test is something that tests your code in isolation from out-of-process dependencies, and integration tests is anything else. And I also put a category of end-to-end tests as a subset of integration tests, and the line between integration tests and end-to-end tests is even more blurry, because it's basically the same thing, but end-to-end tests work with a larger number of out-of-process dependencies directly.
Interesting. In one of your chapters, you kind of dive into what you call the 4 pillars of good unit testing. Could you walk us through those 4 pillars at a kind of a high level?
Sure, yeah. So the 4 pillars are protection against regressions or bugs, and then resilience to refactoring, fast feedback, and maintainability. And let me maybe start with the last 2, because they are the easiest to describe. Fast feedback is pretty self-explanatory. It's how fast your tests give you feedback about the correctness of your software. If your tests work with out-of-process dependencies, such as the file system or the database, then obviously they will not be as fast as tests that don't work with those dependencies. And maintainability is something that can be described as 2 subcomponents of that major component. So the first one is how good your tests are written, how small they are, and how easy it is to understand them. So small tests are usually more maintainable because it doesn't take you much time to read them and to understand. And the second subcomponent of the overarching maintainability component is how easy it is to maintain the environment in which the tests run. So, for example, again, if your tests work with a database or some external systems directly, then you will need to maintain that database. You will need to make sure that it remains operational, because otherwise the test will not be able to run properly. And so some things like, for example, if your tests communicate through the network, you will need to make sure that the network is healthy, that the database is in the correct state, and so on. The most interesting attributes are the first 2, and that is protection against regressions, which is pretty self-explanatory as well, and that means how well your tests protect you against bugs in your software. And that usually is comprised of how much code your tests execute, how much of production code your tests execute. The larger that amount, usually the more protection your tests give you in terms of catching the regressions, catching bugs. The second one is resistance to refactoring or resilience to refactoring. And that is, this metric is about how your tests are refactoring friendly. So, for example, we often encounter a situation where we write some code, we write some tests upon that code, and then we try to refactor that code. Maybe the requirements change, or maybe you decide to modify some things, clean some things up. And so you modify the code base, the production code base, and then what you find out is that your tests are failing. And they fail not because you introduced some bug, your code works perfectly well, just as before, but it's just because your tests were written in such a way that they depend on the implementation details of the production code. And so when that happens, your tests start to produce false positives. And this second metric is basically about how many false positives your tests generate. The lower that number, the better your tests are at that metric. And you can sort of see the first 2 metrics, protection against regressions and resistance to refactoring or resilience to refactoring, as a signal to noise ratio. So the signal component would be the number of bugs your tests find, and the noise component is the number of false alarms those tests raise when they find those bugs. And both of these metrics are critically important, and both of them together they form the metric of test accuracy. So they tell you how accurate your tests are. And they are important because if your tests are capable of finding any bugs in your code base, let's assume that they are perfect in that regard. If they do that with a lot of noise, with a lot of false positives, then they are still not good, because those findings will be basically lost in the a lot of irrelevant information, a lot of noise. And the opposite is also true. Even if your tests don't generate any noise, any false positives, but are not capable of finding bugs, then this test is also bad, because it doesn't do what it is built for, protecting you against regressions. It's pretty hard to find a good balance between the first three components, so protection against regressions, resistance to refactoring, and fast feedback, because when you maximize two of these three components, then you minimize the third one. And so, for example, an example of a test that has good protection against regressions and doesn't generate a lot of false positives is an end-to-end test. So that the test that verifies your system from the end user's perspective. And this test will be very good at these two attributes, but it will be really bad at the third one, because it will run really slowly. And also it will be not very maintainable, because you will need to maintain all those external dependencies that your application refers to. And so it's a tricky balance between these four components, but with some techniques, with some patterns, you can find a pretty good balance that will give you good tests in your test suite.
Nice. And as you were talking there, I started wondering a little bit about, you're talking about like with regressions and bugs that are popping up in your code base. Do you have a strong opinion about, like, let's say when a bug is identified, do you often start maybe yourself or with your teams that you've worked on, where you'll start by trying to create a test that will reproduce and be able to reproduce and see that there's an error in the application if there's like a user report?
Yeah, that's a good technique, actually. So oftentimes you don't have much time to have 100% code coverage. And what you can do, if you're short on time, you can cover the happy path of most of your software endpoints. For example, if you write an API, then you can, for each API endpoint, you can cover a happy path. And then if you encounter a bug, you can sort of switch to the test-driven development mode and don't fix it, but first write a test that reproduces that bug. Then make sure that this test is written correctly and it correctly identifies the problem, and only then fix this bug. And this way, even if you introduce bugs, eventually you will fix them, but you will do that in a way that those bugs will not pop up in the future. That's a very good technique.
Yeah, and I've always wondered if it makes sense at some point to remove any of those or not. If you start introducing, say, things that were specific to like one bug that popped up, just to make sure it doesn't come up again. Or do you find yourself being like, well, we could probably clean this up at some point and not need this many individual things that were just for like a one-off bug thing that we identified at one point?
It really depends. So if this test is a unit test, then there is no reason to remove it, because it's really cheap to maintain, it runs fast, and it doesn't really make sense to remove it. But if it's integration, or even worse, an end-to-end test, then yes. So what I recommend in this case, so if we take the test pyramid where you have unit tests at the bottom, integration test in the middle, and end-to-end test at the top, then what I recommend is, if you cannot write a test that verifies your software at the very bottom of the pyramid, then sure, you have to do what you can, and that is write an integration test or an end-to-end test. But then you need to refactor your code such that it is it becomes testable, unit testable, and then replace this end-to-end test with a unit test, and then remove the end-to-end test. And this way, you will be able to get almost as much benefit as from the end-to-end test, but without the corresponding costs. So without the maintainability costs, and it also will be able to run much quicker.
Do you often work with teams that, say, have a QA engineer?
Yeah, sure.
Where do you see that line or the delineation between what the role of a QA engineer and, say, a developer that's writing automated tests? I'm imagining there's some overlap in these roles and skills, but how have you seen that those roles effectively complement each other in a team?
So it depends on the nature of the QA engineer. Sometimes they can write tests on their own, or sometimes they do just manual testing. I think ideally how the two cooperate is, so I was a QA engineer in the beginning of my career before I became a programmer, and I remember that the most tedious thing to do was to do a regression suite. And because you already did it 20 times before, and now you have to do that 21st time, and it's really very tedious. And this is kind of tests that are perfect for automation, either by end-to-end tests or unit tests, or both. How I see the cooperation between QA engineers and programmers is programmers can easily automate some regression testing, but QA engineers, they can do exploratory testing. So, for example, when you introduce a new feature, those QA engineers can help you explore this feature, make sure that you wrote it correctly, but at the same time, they don't have to spend a lot of time with regression testing. Because, first of all, automatic tests will do that better than them. And second of all is, as I said, the regression testing might be very tedious.
It can be a helpful way of identifying, if you're working on a set of new features and trying to identify different ways you might not be thinking about, or do you find that there's a good balance there of having QA engineers be part of the process of helping you plan out how you're going to approach that feature as well, like during an earlier part of that, earlier on in the discussions?
Yeah, best QA engineers are those who are really into the domain model. So they know, they basically are part-time business analysts. And this way, they will be able to find issues that you yourself as a developer didn't think about. And so, in this case, this merge of two roles, business analyst and QA engineer, is, I think, a perfect mix for any QA engineer. So any QA engineer needs to strive to learn more about the domain model, about the domain in general, and become at least part-time a business analyst. And it's actually true for programmers as well. So when programmers work on some domain, they also need to strive to learn as much about this domain as possible, because otherwise they will sort of become these robots who don't know much about this domain and who cannot really think deep enough about the problem and then because of that they will not be able to write software well enough.
I'm always curious about how teams come in all different shapes and sizes, and how they bring in different types of roles for different things. And I've heard stories from teams where they will bring in people. I've even heard people say, well, it's great to use like interns to do QA. And I'm like, really? Like, are they the best people to try to figure out and understand your business application? You're just throwing some people at the end of the process to see if anything breaks, versus having people that kind of understand how things are supposed to work in your business and say, hey, not only is this maybe not working quite the way we expected it to, but also this doesn't seem to match some of the patterns we had been following over here, and this might be confusing to the end users because we're introducing a different paradigm here, and it doesn't make quite a lot of sense. But to a developer, it could make perfect sense based on the way they implemented it. But I think there's some other aspects to having those people be earlier on in the conversation and not be seen as like someone that's just necessarily just doing some manual labor at the end just to see if they can break something before it gets shipped to production.
Oh yeah, for sure. So in this case, I think what such companies do is that they try to use this labor to do regression testing, and that is the most tedious part, as I said. And a lot of people don't like to do that much, and that's why new people who may be interns or or just new to the company, they are not as tired of this kind of work as the old people, and that's why they are being thrown at this work.
Wonder if that's often just a sign that they hadn't, that as an organization, they hadn't been able to yet invest in streamlining some of their automated testing and process procedures earlier in the life cycle of their products.
Yeah, that's definitely part of it.
What are some common examples of, say, ineffective or low-value unit tests?
So that's a good question. So there are a lot of examples, and I'm trying to think of the most prevalent ones. So I think one of the most prevalent ones are unit tests that have a low chance of finding any bugs, and that is something that I call trivial tests. These are tests that cover trivial functionality. So, for example, in Java or in C#, you have a class with a constructor, and that constructor doesn't do anything. And you write a test that verifies that this constructor basically doesn't do anything. This test doesn't add much value, and the cost of having this test in the test suite will be larger than the benefit it will ever be able to provide. And the other example is, that's an example of a test that is low on the first component, protection against regressions or bugs. An example of a test that is lacking the second component would be some test that couples to implementation details. And the most prevalent example of it is when you write a test that verifies some behavior that you would otherwise keep private. So, for example, in a class, you have a public method and a private method, and you kind of want to verify how this private method behaves, but it is private and you cannot directly unit test it. And so what you do is you can just make it public instead and make your test verify directly. That's not a good approach because, as I said, this is coupling your tests to implementation details. And when you modify those implementation details, your tests will fail. And this will contribute to the noise component of the signal-to-noise ratio and will reduce the test accuracy. Because instead of providing you with the actual signal, with the actual regressions, they will generate false positives.
Quick question. You mentioned public versus private method testing in your objects and classes and such. What is an effective way of approaching, say, private methods that you might not be able to access in the same way?
The best way to approach that is to just test them indirectly. So through the public methods that use those private methods. Basically, your tests shouldn't have any special privileges compared to the production code. They should behave exactly the same as the other code that uses those classes. And so if the other code doesn't use the private method, then your tests shouldn't use it either. So that's one way. And a common scenario, a common objection that I hear here is when the private method is complex and it's not easy to test it through the public method. For example, a common example that I give is, so let's say that you have an order class that generates description of the order. And to generate the description, it's just a string. And so to generate this string, it needs to calculate the number of taxes that goes into this order and calculate, for example, the discount that the user gets. And so if this method that calculates all that is private, then it's quite hard to test the order class using just the public method that gets you the description of that order. And so in this case, what we have here is this is a strong sign that there is a missing abstraction in the code, and you need to extract this complex logic out of that less complex class into a separate class and then test it separately. And so in this case, you make this calculation logic public, and you will be able to test it separately from that first class that uses that logic.
Interesting. I know that, when I don't work in C# myself, I typically work in Ruby land. And, I've seen where we'll work on projects where they'll have really large, like a private method that's just really long. And there's a lot of calculations and other things happening and calling off the different methods and finding it difficult to figure how to best, there's a lack of testing around this area of the application. And well, how do we effectively test this kind of beast of a method or breaking it apart? And then so I see sometimes that people will start refactoring and breaking it up into even smaller, say, private methods that are kind of within the same class, as an example. And then I'm like, well, now it's even feeling even more difficult to test it because now how are we going to interact with this in an effective way? And so I think that's interesting to think about how to extract that out to a different class or something like that, if that's an option.
Yeah, exactly. And when you extract this logic into a separate class, you need to make sure that it really makes sense to extract it into that class, because oftentimes you can introduce a second class just also for testability's sake. But that logic should belong to the first class instead of being extracted. That rarely happens, but sometimes it does. And you just need to make sure that the class you introduce, it makes sense from the domain's perspective, from the domain expert's perspective. So, for example, a calculation logic, as I brought up earlier in my example, it is something that a domain expert can identify as useful. And so that usually makes sense to extract. But something like, for example, an order description. So if you split the order, just you have several fields, several properties in the order itself, and then you have another set of properties that also belong to an order and extract it into something else. I'm not sure if my example makes sense, but sometimes you just need to make sure that you not only have good separation, but also high cohesion between the two. You shouldn't separate things that should belong together.
No, I think, that did make sense. And I think it's helpful to get kind of be able to visualize that, as our listeners are, whatever they're doing right now, if they're on, they're probably may or may not be commuting to work at this point when they actually get to hear it. But the idea that, just thinking about separation of concerns there and how you can try to extract that, some of that logic out there. And so we're just thinking about this. So if you have, let's say, like a really big private method and you move into an extraction thing, do you consider that then if you provide a new class, that's now like a public class that can be interacted with because you're not burying it within like a private area anymore?
I personally like to declare, I'm not sure how it's done in Ruby, but in C#, what you can do is you can declare a class as not the public one, but an internal one. And then it will only be visible inside your assembly. I don't like to do that because you will always have several layers inside your single, for example, domain layer. And you can start to separate them between each other, but it's not very helpful because it entails a lot of maintenance. So in the example with order and the calculation logic, what you could do is you can say that this calculation logic, it's only used by the order class, and so we can make it internal so that it's not used by anyone else. And that's a good approach at times, but I don't quite like to do that because it just introduces a lot of complexity, and so it doesn't help much, so to speak.
We'll be back with our interview with Vladimir in just a moment. Hi, it's me, Robby. I want to take a quick moment to say thank you for making time to listen to Maintainable. If you're finding these conversations valuable, please consider sharing a link amongst your peers and writing a review on Apple Podcasts and or Stitcher. Also, quick tip. Manning, the publisher of Vladimir's book, is offering a promo code exclusively to listeners on Maintainable. Take a look in the show notes for details. Do your part to help authors like Vladimir by picking up a copy, and or perhaps you're looking for a special something gift for one of your coworkers. And now, back to our interview with Vladimir Khoriko. Do you have a strong opinion on how much test coverage an application should have?
Well, I have a strong opinion about how much test coverage your application shouldn't have. So it definitely shouldn't be 100% because at least not the overall coverage. Because so in projects where people strive to achieve 100% coverage, what it usually does to the project is people start to aim not at writing good unit tests, but they start to aim at attaining this artificial target instead, and they try to game this metric. And this is not a very healthy thing to do because unit testing is hard enough already, and you shouldn't put barriers before your programmers in the form of artificial metrics that you should achieve when doing that unit testing. The main idea here is that you shouldn't strive to achieve 100% test coverage because it's mostly impossible without introducing some low-level tests. What you should aim at instead is you need to make sure that you don't have too low test coverage. So, for example, anything less than, say, 50% is a good sign that you don't have enough tests. And how I like to describe it is, I like to say that code coverage metric is a good negative indicator, but it is a bad positive one. And so it is something that can tell you. So, for example, as I said, if you have low test coverage, that's a good indication that you don't test enough. But even if you have 100% test coverage, it doesn't mean that much. You still may have tests that are of low quality and tests that you need to refactor in order to improve your unit test suite.
Touching a bit on, code coverage there and like having maybe too much or too little or the wrong type of test. I can imagine people saying it's a matter of having the right testing. And I think sometimes it's difficult for people to understand exactly what that might mean in all scenarios. Under what circumstances would you advocate for deleting existing unit tests?
Yes. So for example, if your tests overlap between each other, then they should definitely be deleted because the marginal benefit that the second test provides is close to zero, so there is no benefit in having it in your test suite. And you can categorize all your code in your project among two dimensions. And the first one is code complexity and domain significance. So, for example, your domain model would score highly on that dimension because this is the code that is very important for your project. And also, if you have some algorithms that do some complex calculations, they will also score highly on that dimension. And then the second dimension is the number of collaborators that your code has. So this would be something like, for example, when you have a customer as a system under test, and this customer needs to communicate to the organization class. So this organization class would be a collaborator for the customer. And then those collaborators could be in process. For example, other domain classes are in process or out of process. Out of process are dependencies such as database, the file system, the third-party systems, and so on. And so when you plot your code on that diagram, you have 4 squares on it. So let's say that the first dimension, the code complexity dimension, is the x-axis, is the y-axis, is the y-axis. And the number of collaborators is the x-axis. And so on the left top corner, you will have your domain model and your complex algorithms. And this is the part which doesn't have a lot of collaborators, but have a lot of either domain significance or code complexity. And this part is the part that benefits from unit testing the most, because it's quite easy to cover it with tests, because those tests will be easy to maintain and will be cheap to write. Because what makes a test hard to maintain is when it starts to work with a lot of collaborators. So when you have a lot of dependencies you need to supply to the system under test, then it becomes really hard to maintain this test, especially if those dependencies are out of process, such as the database. And But at the same time, because there is a lot of complexity in that code and a lot of domain significance, those tests that cover this part of your code, they have a lot of protection. They provide you with a lot of protection against regressions. On the other hand, on the opposite side of that spectrum, so on the lower left corner, you have trivial code that doesn't have a lot of collaborators. So, for example, in C#, it will be some properties, just for example, customer name property. This part of your code shouldn't be tested at all, because such tests wouldn't provide you with significant enough protection against regressions, and so they will basically be trivial tests. You definitely need to remove those because, as I said, they don't provide you much value. On the third quadrant, where you have many collaborators but not much complexity or domain significance, that quadrant is called controllers. So this code is something that combines your domain logic with the out-of-process dependencies. So, for example, when you receive a call from the external system, for example, if you have an API system, then the first thing that this external system hits would be your controller. And this is the part where you sort of combine everything in one place. So this controller would be responsible for cooperation between different subsystems, including your domain model. And the fourth quadrant is something that I call a messy code, so overcomplicated code. And this is code that has both high complexity and a lot of collaborators. And that would be something like overcomplicated controllers that don't delegate the work to the domain model, but instead do everything themselves. So in your example that you provided earlier, that would be the class with large private methods. So it tries to do everything by itself. So and what I recommend you do is, as I said, you shouldn't test in the lower left quadrant at all. So that would be trivial code with few dependencies. You need to have close to 100% unit test coverage for the upper. So for left up quadrant, that would be the domain model, high domain complexity, and few collaborators. And you also need to test your controllers, but that would be integration tests. And this quadrant doesn't require as extensive unit testing as the domain model quadrant. So here you can basically have a couple of integration tests that maybe verify the happy path and some most important edge cases that you cannot verify with unit tests. And as for the fourth quadrant with overcomplicated code, I'd also don't recommend that you test it. And what I recommend you to do instead is you need to refactor that code into the domain model quadrant and to the controller quadrant. So basically you need to introduce the separation between the business logic and the coordination responsibility. Do you find that thinking through that quadrant there, and you're saying you shouldn't write tests for that bottom right quadrant, do you think it's there's a fear in developers of trying to refactor if they weren't part of the process of building out the code that's in that bottom right corner to move it out because it looks confusing and they maybe don't feel like they have their head completely wrapped around? Do you have some advice on how they? You mean the quadrant, the more complicated quadrant? There are definitely some challenges when you try to refactor it. For example, if your code doesn't have tests, then basically how we are going to do that? Because when you refactor, you need to have tests. On the other hand, to have effective tests, you also need to do this refactoring first. So in this case, what I recommend is you need to start from the top of the test pyramid, and first you need to write end-to-end tests that verify the system from the end user's perspective, or maybe some integration tests. And then when you refactor, you can push your tests down the test pyramid and replace those integration and end-to-end tests with unit tests. So this will allow you to untangle this circular dependency between the test and the code refactoring.
That leads me into another topic here. Do you find yourself more often on team rewrite or team refactoring?
Oh, so that's a great question. I have a strong opinion here, and that is you should never rewrite your code from scratch unless this code is really small. And I remember Joel Spolsky wrote a great piece back in 2000s, and it is still relevant today. And the TLDR of that piece is that you shouldn't ever rewrite your code from scratch, because so what I personally find is that there are a lot of baked-in assumptions in this process about the benefits of that rewrite. And these assumptions are usually that the new version will become better than the previous one, but it's not guaranteed at all that the new version will be better than the first one. But the cost that you introduce with this rewrite, the cost for the business are very real, and they are guaranteed to be there. And so there is a huge disconnect between the two, because you introduce a lot of risks in this rewrite without clear benefits. So I understand where it comes from, because we as software developers, not all of us, but a lot of us like to work on greenfield projects, don't like to maintain legacy software much. And so why developers are getting that excited about full rewrites is because they get to work on greenfield project even when they have this legacy project. So they don't want to work on that legacy project, but the greenfield project, the greenfield rewrite, on the other hand, is much more exciting. And so I understand that where this comes from, but it's not very beneficial for business. And there is this tug of war between the needs of the business and the preferences of developers, where the business needs you to maintain the legacy software, the legacy project, because it provides, it is what makes this business money, basically. But developers don't like to do that, because that legacy project is often not very well maintained, all that stuff. So it's not pleasant to work on the legacy stuff. And so what you need to do is you need to find middle ground between the two, because it's not so both of these extreme ends are bad for the project and for developers and for the customer. Because, as I said, when you try to do a full rewrite, then you're hurting the business by introducing a lot of risks to this rewrite. But on the other hand, when all they do is maintain their legacy software, then they quickly become discouraged and their productivity falls as well. And so the middle ground here is you need to gradually refactor your project such that you combine the benefits of both. So you still maintain the legacy system, but at the same time, you try to introduce the green fieldness, so to speak, to some parts of that project. And so what you can often do is, well, it actually depends on the kind of project that you have. But for example, in domain-driven design, there is this concept of a bubble context where you introduce a new bounded context in your system and separate it from everything else using an anti-corruption layer. And it's a good practice to introduce new features with refactoring of the existing code. So, for example, if you need to fix some bug in the project, that's obviously something that you need to do in the legacy project, in the legacy code base. But when you need to introduce a new feature, you can introduce it using this new bounded context. And you can do that using your clean code that is separated from the surrounding mess. And so a good practice here, if you're going to continue with the refactoring, so a good practice is to expand this bubble context slowly, so gain more territory, extend it, refactor the old code, and eventually it's the legacy code base, the legacy mass will become a separate bubble, separated from your clean project, and your clean project will basically be the majority of your code base.
Nice. Earlier on, you were touching on like ways that teams might prioritize or find ways to organize maintenance and or refactoring tasks amongst, say, their product backlog when the business is looking to ship some new features or some new big updates to their customers or their end users, and trying to maybe finding there's some different tactics. One, they kind of sneak it into the work that they're doing, and maybe they just schedule ahead for it. What sort of advice do you have on like just organizing that type of work? If it's not necessarily let's say if you've got a bunch of user stories or however your team's organizing the work to be done, do you find that it's better to have individual tickets or cards in your systems to say, we need to refactor this area? Or is it that how have you seen that work out well? And then to try to like bring that into the fold with your typical workflow with how you're shipping new features and updates with your team?
So that depends on how significant that refactoring is. If this refactoring doesn't affect much of the rest of the code base, then you just need to do that without asking. So basically, it's like you're writing a test. You don't need to ask a permission from your manager to write a unit test. You just need to do that. But if this refactoring kind of affects the rest of the code base in a significant way, because it's not always possible to refactor just one thing in your code base, because if it's a mess, then it usually entails changes so the changes usually ripple across the whole code base. And what you need to do here is you need to really think hard about how you can isolate your changes from the rest of your code base. And one way to do that, as I said, would be to introduce an anti-corruption layer, but there are other ways. And so in this case, you will have to communicate with your management about this change and try to describe the benefits of that refactoring, so of reducing this technical debt, so to speak. And yeah, that should be a separate ticket then, because otherwise you will just not have enough time to do that.
I have a few last quick questions for you. One, this is kind of like a somewhat hypothetical scenario. Let's imagine that there's a few people listening to the podcast right now, and they feel like their concerns about the long-term health and maintainability of their code base aren't being heard by, say, the product owners or stakeholders, and in terms of improving the underlying code base. And maybe they've heard the phrase, not right now, maybe later this year, a few too many times, and are starting to feel like it's no longer worth asking. What advice could you offer them on how to take some action today?
So as I said, if that's something small, then no need to ask. But if it's something significant, it's really hard, because if you don't have much say into the direction of the project, then unfortunately, I don't see any other option other than to leave the project or just grit your teeth and go along with the needs of the business and just maintain the legacy project. Because if it's something more significant than just some cleanups here and there, you will have to have permission from the management, because it's just not possible to do otherwise, unless of course you don't have a lot of other tasks, in which case you can just do the refactoring on your own between the other things that you do on the legacy project.
That makes sense. I think there's always that challenge there that people might have and feel like leaving and finding a new place to work is always an option. They'll have to find someone to deal with this stuff at some point. And so I think that there is also the option of maybe talking with your manager, be like, hey, this is the type of thing that prevents people from wanting to continue working here. And retention is probably a big interest on their end as well. So I think there's not necessarily you need to threaten your job and you're going to quit if you don't deal with it, but
yeah, exactly. You need to clearly communicate all the benefits and all the drawbacks of keeping the status quo, for sure.
What non-software development related book do you find yourself most often recommending to people in our industry?
I think the most important non-software related thing that you can learn is how to deal with your habits. And there are quite a few books on this topic, but I think the book I liked the most is Atomic Habits book by James Clear. It really helps you set up a framework for working on your habits, because that's some little things that you will be able to, that will help you improve in the long run.
It's a lot of those little things. I think a couple of other guests have mentioned it too, and I've not picked that book up myself, and maybe it's time to do that now that I have all this time on my hands at home. And where can listeners best follow your thoughts on software development online?
So I have a blog on enterprisecraftsmanship.com, and also, as you mentioned, I recently published a book, so the book about unit testing. And so just go to, well, actually, the easier way to find me is to go to painlessunit-testing.com and to subscribe there. That's just a domain name that is easy to remember.
Well, excellent. It's been such a delight having you on Maintainable, Vladimir. Thank you so much for joining us.
Oh, thanks for having me. Thanks a lot.